So in this video, we're going to look at how to implicitly differentiate an expression. So it says find the derivative of each expression. So here I want to find d dx of y cubed. And before I just jump into this, what I want to think about is what would I do if I were trying to find d dx of other things that were being cubed? So what if I wanted to find d dx of the cosine of x being cubed, or d dx of x squared minus 2x plus 1 being cubed? And what we want to recognize is from the previous homework and video sets that this would require the use of the chain rule to do. We have one function inside of another, or we have function composition, which requires the use of the chain rule. So to take this derivative, we see that the outer function is the cubing function. So we would use the general power rule to take the derivative of the outer function, and then we would take and multiply that by the derivative of the inside function. And we would take the derivative of the outer function at the inner function. And then we would finish this off by taking the derivative of the cosine, which is minus the sine. So we would get negative 3 cosine x squared, all squared. And to get the squared, I would put this actually in the hook. We would go cosine squared of x sine x. So this one would be the same song and dance. We would say, hey, I have a function composition. I have the second degree polynomial inside of the cubing function. Take the derivative of the outer cubing function, but take that derivative at the inside function, and then multiply by d dx of the inside function, x squared minus 2x plus 1, which would give us 3x squared minus 2x plus 1 quantity squared times x squared, derivative of this is going to be 2x. d dx of x squared is 2x minus d dx of 2x is just 2. And of course the derivative of 1 is 0. So we're going to play this out the same way if this is a y. What we're going to recognize is this is a y being cubed. So to find the derivative, we're going to take the derivative of the outer function, the cubing function. So I'm going to get 3 times y, just like I did over here, squared, times, but because this y is inside of that cubing function, we need to take and multiply by the derivative of y. So we need to take d dx of y. But the derivative of y with respect to x is just dy dx. So we would wind up getting 3y squared dy dx, or 3y squared. Remember that y prime and dy dx are synonyms, so we could just write 3y squared y prime. The key is to notice is that the process is the same in each of the 3 cases. We have something being cubed, something being cubed, something being cubed. For each case, we need to use the chain rule. So in this case, because this is y implicitly defining some function of x, we call this utilization of the chain rule to take the derivative d dx of y cubed. We call it implicit differentiation. Implicit differentiation. So in other words, y is implicitly defining some function of x. Here I knew what the function of x was, so I could just take its derivative. Here I knew what the function of x was, so I could just take its derivative. Here I don't know what the function of x is, but I'm still going to take its derivative.